Chapter 1, Lesson 3. Notice the assignment here, 1 through 10 and 12 through 18. Again, I'm trying to make these shorter so that we can get through them in a reasonable amount of time. We'll also do some review at some point, but let's get going here. So today you're introducing angles, measuring and constructing angles. Remember constructions, we're not actually doing those till later. So this is specifically about angles and how to name them and make them. So there were some typos here, and I see when I tried to fix it, but it didn't quite fix it. But in this picture, when we name an angle, like angle R here, we can name it several ways. You heard me say it, angle R. I could also call that angle 1. I could call it angle SRT or TRS. The important thing is that when you name an angle, we usually name it with 3 points. When you name an angle, the vertex must be in the middle. That's this point right here, the R. So that's where the two rays that form the angle meet. You always have to put the vertex in the middle. SRT is okay, angle. Put an angle symbol in front of it, like here. Or you could say angle TRS. So they're calling this the interior of the angle and that the exterior of the angle. That's not something we talk about much. Make sure when you name an angle, you put the vertex in the middle. Again, we're having some issues with typos, but this is angle QTS, the big angle, or QTR, that's the top smaller angle, or RTS. And I can flip that around as long as I put the T in the middle. RTS or STR or STQ. I cannot say in this case angle T. Look up above at angle R right here. There is no doubt about what angle R is. There's only one angle there. But right here, angle T, there's several different angles and I can't tell which one's angle T. So always, if there's more than one angle, make sure you use 3 points, or you could use a number, and that would be specific. That top one's supposed to be angle 1, the bottom one's supposed to be angle 2. So we measure angles in degrees, and the way they defined it is there are 360 degrees in a circle. So if we divide that in half, it's 180, half a circle. Or a quarter of a circle would be 90 degrees, which you know is a right angle. Now, you might remember on a previous assignment, we talked about the ruler postulate. That gave us the ability to put numbers on a number line and find distances. The protractor postulate is the same exact thing, it's just you're doing it with angles. So now we can put numbers on an angle and measure them. To do that, we use a protractor. So just like with the number line, all I need to do is take the two angles and subtract them. And if I get a negative, I just make it a positive. That's why the absolute value, it means always positive. So like right here, if I wanted angle DOC or COD, all I would do is take 135, that's where that is, and subtract 65. Subtract those two and you'll know what that angle is. And if I do it in the wrong order, 65 minus 135, that's fine. I just make it positive. Now you've talked about these before, I'm sure of that. Acute angle, less than 90. A right angle, 90. Obtuse is greater than 90, less than 180. And a straight angle is an angle that makes a straight line. Again, we usually use 3 points to name a straight angle. They didn't give us 3 points here. But I could, if I had an A, B, and a C, I could say the measure of angle ABC is 180. So you'll notice below the little M, you heard me just say it, that's the measure of angle AOD. Notice that when they use an M, they're using an equals. So if I put an M in front, I know I'm talking about a number, and numbers are equal. That's why we don't use a congruent symbol, and we will use congruent symbols sometimes. But congruence refers to shape. Whereas when I have a number, I put an M, and we're saying it's equal to some number. Um, there's some examples you can look at. They have the answers just to make sure you understand. Remember how we talked about congruent segments? Well, now we're talking about congruent angles. Remember the tick marks on congruent segments? Well, here we use arc marks. We're saying if we put 2 arc marks on both of them or 3 arc marks, we're showing that they correspond, that they're congruent. You can do this a variety of ways, and you'll see that later. But congruent angles means they have the same size and the same shape. And I want to call your attention to, very important, remember, M means measure. Numbers are equal. So when I put an M in front, I'm talking about a number, and they are equal. Their measures are equal. If I use a congruent symbol, I do not use an M, and this means they have the same exact shape. I could pick one angle up, turn it, place it perfectly on top of the other. Congruent means same size, same shape. Constructions we are skipping for now, and down at the bottom, the angle addition postulate. So this is exactly the same thing as the segment addition postulate. It's just that it's with angles instead of segments. Remember how I told you that the segment addition postulate said that 2 segments made a big segment? Well, here I'm saying that 2 angles make a big angle. Notice the M. We're talking about numbers. And if I put a number, if I'm doing numbers, I can add them. So there's the plus. And of course, they're equal, not being congruent, but equal to the measure of some other angle. So what they're saying is that angle they marked in red, SQP, plus the measure of the angle I marked in, I think that's blue. I'm colorblind, by the way, guys. RQS, that angle over there, those 2 smaller angles make a big angle, RQP. And again, remember, I could flip that around. The important thing is I put the vertex in the middle. The angle addition postulate says that 2 angles make a big angle. And they have some examples here. And specifically what you're doing is in the homework, this is exactly like the homework. You'll be adding sometimes 2 numbers or maybe subtracting 2 numbers to find the angle you need. So if you're ever in doubt, make sure you're drawing a picture, label the angles with their measure, and think about it. And again, they have some examples. You have answers there provided. So you might remember we had a segment bisector. A segment bisector could be a line or a ray that passed through the midpoint of a segment. It divided it into 2 equal parts. An angle bisector is a ray that divides an angle into 2 equal parts. So if I have an angle bisector, in this case, ray JK, it bisects or cuts in half angle LJM, and I get 2 congruent angles, LJK and KJM. An angle bisector divides an angle into 2 equal angles. And we'll get to do this construction later. Some more examples, just like the homework. And we're on to the homework. Now, let me point out a couple of things, and that way you can get through this more quickly. So don't forget that the vertex is always in the middle of an angle. And when I name a ray, I say where it starts. They call that the endpoint. OA is a ray. OC is a ray. OB is a ray. When I name these angles, I can do them different ways. I can call them angle 1 or 2, and that's okay. If I'd rather say angle AOB instead of angle 1, that's okay also. But don't forget, besides angle 1 and 2, or those smaller angles, you can use 3 letters. You've got the big angle, AOC. So that's what you're doing there, naming all the angles in the diagram. On 4, 5, and 6, you're going to be subtracting 2 numbers to find the angle you need. Be aware that when you measure an angle with a protractor and you pick a scale, stay with the same part. So if you use the outside, make sure you're using that outside all the time, or the inside. And usually we start at 0. Like if I want to measure RXS, I'll start at 0 here and I'll go 20 minus 0, it's 20 degrees. I can see it's 20 degrees. When you do 7 and 8, draw a picture. And they say L is in the interior. So you're going to put a point inside the angle and draw a ray there. It'll be KL that you're drawing. Put some numbers in there. Find JKL, put a 42. Find LKM, put a 28. It doesn't have to be to scale, meaning it doesn't look quite right. That picture's what you need to figure it out. Again, sometimes you'll add those angles, sometimes you'll subtract those angles. It'll be a variety. 9 and 10, and those are like 17 and 18. When they say that it bisects, remember that it cuts it in half. Now that might mean these two angles are equal, or it might mean that you need to take twice one of these angles and set it equal to the other. Again, draw a picture. Draw angle ABC, and there's B, the vertex. Draw in BD that cuts it in half. And look at these angles, ABD and DBC, and mark them on the picture and see if you can't figure this out. Now, if you get stuck on these, that's okay. Remember, I got a day there to help you. And number 18 gives people trouble sometimes because of the 5 halves. When I set up my equation, I just multiply everything by 2, and that eliminates the fraction. That's the way I like to do things. So you should be able to get through this fairly quickly. There are lots of important vocabulary on this assignment, vocabulary words. Angle, vertex, idea that the vertex is in the center. We know what degrees are. Make sure you know the acute, right, obtuse, and straight. And you've got to know how to mark congruent angles. And it's really important you understand the difference between saying things are equal using measure and saying that their shapes are the same using congruence. The idea of a bisector is also very important. Now, you've got at least one day to ask questions. Remember, I have office hours every day from 12 to 12:30, except Wednesday. I'm glad to help you anytime. Get to work.